content. I'm finally facing it all. Fearless.
Hello guys, I hope that you will be really very fine this day. In the previous video we have just made the obstacle avoiding robot. So today in this video we are going to make a line following robot that is entirely different from the previous ones. So as a user requirement we are asked to make a line following robot using mux. So we will use the rudimentary logic using the mux. So let's dig in. So here we go, this is the truth table for these four sensors and the output as the two motors. So here you can see that these columns are showing you the motor left and the motor right operation, and these are the inputs for these sensors. Here you can see that this is the tail sensor, this is the left sensor, and this is the center sensor, and this is the right sensor. Here you can see that the sensors which are placed at the top of the rover will be the left, center and right sensor, and this will be the tail sensor. And you can see that if both of the sensors, four sensors were off, then you can see that the left and right sensor will be off. And then you can see that if the only right sensor get turned on, then the left motor will be turned on to move right. So as you can know that both of the sensors, when both of the sensors will be turned on, so here you will see that it will also move left. And then if you can see that only the left sensor will be on, then the right motor will move the mover to the left position. And then you can see that if the right and the left sensors are turned on, then both of the inputs will be 0 because this is the abnormal situation. So this is the truth table, and after that we will implement the rudimentary logic for that. And here you will see that the rudimentary logic for the left motor that I have implemented is this. So these are the inputs for the previous sensors that I have already explained, but I'm just using for left motor the rudimentary logic will be the same as for the right motor as well, so you can also implement it by own self. So here you can see that I have to just compare it with any of the one input, and then we will see that the SR is quite matching with it. So here you will see that the 0 and 0 and 1 and 1, so these two are matching with the SR, so we will name it as SR. And after that you can see that both of these are 1, so we will name it as 1. And these are 0 0, and this will be named as 0, and this is SR because this is 0 and 0 and 1 1. Similarly they are matching, and this is 1 1, this is also 1, and this is 0, and this is SR dash because this is opposite to the odd. So 1 2 3 4 5 6 7 8, these 8 pairs we have made. So we will connect it with the input terminals of the 8 cross 1 mux. So here you will see that these will be the selection lines. So the other 3 inputs of the sensors that we have not compared with the output of the motor in the rudimentary logic, so we will just use it as the selection lines. And then we will these are the 4 inputs here and the 4 here. So this is called as 8 cross 1 mux, in which the voltage at here and the ground at here will be applied, and the output at the 5th terminal of this IC will be obtained. So let's go to implement that circuit on Proteus. So here we'll see that. So this is the entire structure to build a robot on simulation in PCB. So here you can see that this is the Proteus simulation for the entire model that we have implemented using the rudimentary logics in Max. So here you can see that this is the right sensor, left sensor, tail, and this is the center sensor. So here you can see that the two of the motors that we have used by using the motor driver, and here you can see that this is will be applied with the positive 12 volt, and this is the 5 volt, and this will be grounded. This all will be grounded as well. So these two inputs will be applied by the outputs of the two mux that we have used for left and right motors as well. And here you can see that this is the right motor and this is left motor connecting. So as you can see that if I turn off the tail sensor and just turns on the left sensor, or sorry, right sensor, so here you will see that the left motor will be turned on as expectations. So and let's say that if I turn on the center sensor, then you will see the logic table that the motor will still remain turns on. So if I move on towards the opening of the left motor and the closure of the right sensor, so then you will see that the right motor will turn on. So to turn on these both type of the motors, then you will see that the center sensors will be turned on, and then it will make the two motors to move. So here you can see that both of these motors are moving. So the first thing that I just want to make you learn is that these are the two inputs that are the permanent inputs that I have applied to the mux. So here you can see that these are the zeros and ones. These were the permanent inputs that will be applied to the both of the muxes depending upon what type of the rudimentary logic that you implement. So here you will see that for this you can say that the 1 will be the 5 volt and 0 will be the ground. So when applying the inputs and the outputs to this both of the mux in the PCB simulation and PCB, so you will connect these terminals with the input and negative, positive and negative terminals of the batteries as well. So here you can see that these are the LEDs to show only that whether the sensor is working or not, but you don't have to implement that on the PCB. So while moving on towards the implementation of the PCB, actually these sensors doesn't exist while you just make the PCB, so you have to just make the connectors. So we will just implement these 2-pin connectors, and these will be the silk connectors depending upon the 1 2 3 4 5 6 7 8 9 10 11 and 12, and these two outputs will be 14. So we will use the 14 pin connectors to implement this. So here you can see that I have made another circuit for that, and you can see that I have used the 14 pin connector for that, in which the 3 sensors simultaneously will be placed, and then you can see that the output of these 2 sensors is also here, and we will connect it one by one with the inputs of the motor driver as well. So this was this entire circuit, and after the implementation, then you will see that I have made it. I have already uh, implemented the PCB. You have to just arrange all these and you don't have to make any type of the connections. So the one thing that you have to do is to just pick up these connectors, square hole pads, and then put it here after selecting the suitable hole or diameter what you want. So I have just used these square connectors to increase the area of the solder to be stick here. So these are this is the PCB, and I have just used the auto routing command to auto route this entire structure. After that, if I go towards the 3D visualizer, you will see that the PCB like this will be created, and the bottom of the PCB will be like this one. So here you can see that these are the silk connectors. 2 silk connectors are connected here, and the remaining are here. So let's move on towards the implementation of this into the practical life. So for its entire construction you need the following rover set with the battery jacket included, jumping wires, L298N motor driver, battery cells of what you need, ferrichloride, and last but not least the double layered copper board. So here I will use the printer jet ink as the maskant to apply all the pattern. I have this used the ferric chloride to perform the etching operation, and after soldering I have just created all the PCB, and here you will see that I have just made the connections as in the previous Proteus diagram. So after adjusting the sensors in the right way, it is the time to practically simulate the rover.
Burning the bridge that
So if there is any query and confusion related to this project, kindly let me know in the comment section. If you really like this video, don't forget to like, share and subscribe my channel as well. Thank you.